Let's take a look at the examples for chapter 10. True and false questions. The hypothesis statement where HO mu is equal to 25 is an example of an alternative hypothesis. This is false. That's the null hypothesis, not the alternative. The hypothesis statement HO has x bar equal to 100 is an example of a null hypothesis. This is also false. We do not test for sample statistics, only population parameters. The hypothesis statement HA with mu less than 60 is an example of an alternative hypothesis. This is correct. The purpose of hypothesis statements is to draw a conclusion about the population parameter for which we do not have complete knowledge. This is also true. The hypothesis statement HO mu equal to 90 is an example of a one-tail hypothesis test. This is false. This is a two-tailed hypothesis test. For a one-tail lower hypothesis test, if the Z or T test statistic exits the critical value, we do not reject the null hypothesis. This is true. And when the p-value is greater than alpha, the conclusion for the hypothesis test is to reject the null hypothesis. This is also false. Let's take a look at the multiple choice questions. If the purpose of the hypothesis test is to establish that a population parameter is equal or not equal to a specific value, the equality statement is always assigned to the null hypothesis. A golfer claims that his average golf score at the course he plays regularly is less than 90. The correct hypothesis statement for this golfer to prove his claim would be, so less than 90, I'm giving you HO or HA. Less than does not contain the equal sign, so mu less than 90. That would mean that the null hypothesis would be the exact opposite with the equal sign. So the correct answer would be D. The National Association of Realtors reported that 26% of home buyers in the state of Florida are foreigners. When testing the validity of this report, a type 1 error would occur if it was concluded that the proportion of foreign buyers was not equal to 26%, when in reality the proportion was equal to 26%. This would be the type 1 error. YouTube would like to test the hypothesis that the average length of an online video watched by a user is more than 8 minutes. We have a random sample of 37 people watched online videos, and is equal to 37. For x bar equal to 8.7. It is believed that the population standard deviation, this is where you want to focus, this is your sigma, is equal to 2.5. YouTube would like to set alpha as 0.02. The critical value for this hypothesis would be, so let's examine what we have. We have a hypothesis set where mu is greater than 8. Therefore, for HO, mu will be less than or equal to 8. That's step 1. We want to find the critical value for this hypothesis. Since HA has mu greater than, that means I have a one-tail test, and it's going to be right. So automatically you know that your critical value will be positive. Since sigma is given, I have a z-test, and when I have a z-test, I find the critical value by doing 0.5 minus alpha, in this case, because it's a one-tail. So 0.5 minus 0.02, 0.48. We go to the Z table, we see what value 0.48 corresponds to. You look inside for a match to 0.4800, outside for the critical value, which in this case will be 2.05. So this point here will be 2.05. That's going to be your critical value. So the correct answer will be A. Now, for the same problem, we want to find same information as the previous one, the test statistic. Once again, we have a Z test statistic, x bar minus mu over sigma divided by square root of n. X bar is 8.7 minus 8 over 2.5 divided by square root of 37. So this will be equal to 1.7032. Now, for the same example, we want to calculate the p-value for this hypothesis. To calculate the p-value for this hypothesis, we use our graphing calculator to calculate the test statistic. So stat test, it's a Z test, enter. Under stats, you will have mu 8, sigma 2.5, x bar 8.7, and 37, mu. In this case, we want to see if it's more than, and calculate. So the p-value will be 0.0443. This should be 3. 0.0443. Number 7. The Department of Education would like to test the hypothesis that the average debt load of loan of graduating students is equal to 17,000. A random sample of 34 students had an average debt load of 18,200. The population standard deviation for the student debt is 4,200. So we have n equal to 34. We have x bar equal to 18,200, and we have sigma equal to 4,200. We want to calculate the test statistic. Once again, we have a Z test statistic, x bar minus mu over sigma divided by square root of n, 18,200 minus the mu, which is 17,000, over 4,200 divided by square root of 34. If you do the calculations, you will have 1.6666, which will be, round up to the second decimal, 1.67. Again, make sure you use your parentheses when you do the calculations. The Department of Transportation would like to test the hypothesis that the average age of cars on the road is less than 12. We have n equal to 45, average of 10.6, sigma equal to 4.1. The correct hypothesis statement for this hypothesis test will be less than 12. I'm giving you HA, mu less than 12. That means that HO would therefore be mu greater than or equal to 12. Therefore, the correct answer will be B. Now, for the problems, AT&T would like to test the hypothesis that the average revenue per retail user for Verizon wireless customers equals to $50. We have a random sample n equal to 32. We have x bar equal to 54.7. We have, it is believed that the population standard deviation, that means sigma is equal to 11. alpha is equal to 0.05, use the critical value approach to test the hypothesis. So equal to 50, this is what they want to test. That means that we state the hypothesis first. Mu is equal to 50 or mu different than 50. Step 2, we calculate the test statistic. Since sigma is given, we are going to have a z test, a z hypothesis test, therefore a z test statistic. So the test statistic would be equal to 54.7 minus 50 over 11 divided by square root of 32. Your test statistic will be 2.42, and once again you can use your graphing calculator for this. Step 3, critical value or critical values. In this case, you look at the alternative hypothesis. You have a two-tailed test. That means you will have two rejection areas, two critical values. Since I have a z-test, I find the critical values by doing 0.5 minus alpha divided by 2. So 0.5 minus 0.05 divided by 2. This will be 0.475. 0.475 will give you critical value of plus minus 1.96. So this point here will be negative 1.96. This point here will be positive 1.96. So the conclusion, you will take 2.42 and you will check if it falls on either rejection area. 2.42 is greater than 1.96. That means it falls inside the rejection area. Therefore, the conclusion will be that we reject HO. That means we have enough evidence to support the fact that mu is different than 50. AT&T would like to test the hypothesis that the average revenue per retail user for Verizon Wireless customers is equal to 50. A random sample of 32 wireless customers provided an average revenue of 54.7. It is believed that the population standard deviation for the revenue per retail user is $11. AT&T would like to set alpha for 0.05, use the p-value approach to test this hypothesis. So in this case, I have the exact same problem. The only thing I'm changing is the way I conduct the hypothesis set. For the p-value approach, once again, we have HO mu equal to 50. We have HA with mu different than 50, and then we find the test statistic. So if we were to use our graphing calculator for that, we would go to stat, test, z-test, mu would be 50, sigma 11, 54.7, n is 32, mu would be different than, and calculate, enter. So we have 2.42 if we round up to 2 decimals. And I also have the p-value right here, where the p-value is equal to 0.0156. So all I need to do is take the p-value and compare it to alpha. Once again, alpha is 0.05. So alpha is equal to 0.05. 0.05 is greater than 0.0156. Since the p-value is less than alpha, then we reject the null hypothesis. We reject HO. Enough evidence to support the fact that mu is different than 50. So now you have the same problem solved in two different ways as far as the hypothesis testing is concerned. Problem number 3, we have, based on that, on the problem, we have n equal to 15, we have x bar equal to 7.02, we have s equal to 0.4, we have alpha equal to 0.05. The hypothesis set, we basically want to check if mu is 7.2, the alternative therefore will be mu different than 7.2. S is given, therefore I will have a t-test. So the test statistic will be equal to 7.02 minus 7.2 over 0.4 divided by square root of 15. If you do your calculations, this will be negative 1.74. Since HA has different than, mu to be different than, we know that we're going to have a two-tail test. That means two rejection areas. To find the critical value, we will go to t-table, third row for alpha equal to 0.05, and degrees of freedom 14. If you look it up, you will find a t-value of plus minus 2.145. So this is going to be negative 2.145. This is going to be positive 2.145. So negative 1.74, your test statistic, falls outside the rejection area, somewhere over there. Therefore, the conclusion would be that we fail to reject the null hypothesis. We fail to reject the null hypothesis. That means not enough evidence that mu is different than 7.2. We do not have sufficient evidence to support the alternative hypothesis. Now, for problem number 4, you are given n equal to 18, x bar equal to 148.5, s equal to 34.9, and alpha equal to 0.01. We want to test the hypothesis that those celebrating Valentine's Day will spend more than an average of 125. More than means that I'm giving you the alternative hypothesis, mu greater than 125. Therefore, your null hypothesis will be mu less than or equal to 125. Now, since S is given, we're going to have a t-test. To find the test statistic, we will have x bar 148.5 minus 125 over 34.9 divided by square root of 18. Again, you can use your graphing calculator or you can do the calculations manually. If you do your calculations, this will be equal to 2.86. We have a one-tail test. We check the alternative. A one-tail test upper. That means the rejection area will be to the right. And again, I know that it's going to be right because the alternative has mu greater than. We always check the sign of the alternative hypothesis. Since I have a t-test, I find the critical value by going to the t-table, second row for alpha 0.01 and degrees of freedom 17 and degrees of freedom 17. So the critical value will be equal to 2.567. So this point here will be 2.567. So for the conclusion, you will take your test statistic and you will check if it falls inside the rejection area. 2.86 is greater than 2.567. That means it would be somewhere, let's say, over here. So the conclusion would be to reject HO, enough evidence to support the alternative hypothesis. And this concludes the examples for chapter